Yeah. Yeah, no problem. Rather have you be early than late, you know. Yeah, I know it. I wish I abided by that more. I feel the same way though. All right. Okay, I do have a charger. You have like a lightning or USB-C?
Just a regular, not USB-C.
The other one. Okay. Yep, I have chargers. Not the Blue Book app. Nope, on the website. This one, right? Okay. Let me get you plugged in over here. And this is a fast charger too, so should get some juice there soon. Working? Okay, good. Mm-hmm. Oh, good. So were you able to do the reading section? Okay. Did you find it on there? So under, let me see if I can pull it up on here so I can show you. Okay. All right. So under College Board, you're going to go to, let me go back to the home page here. Okay. Under sign in at the top with the little person there, you're going to sign in using your student account. This is not the right one. Okay. Back to sign in here. This thing. I'm gonna need for that to go away. There we go. Okay. You're gonna see a My SAT page. Oh, this is putting me into, yeah, it's not gonna show me on here. Okay. Let me just show you on yours. I'm gonna go to, yep, right there. Should be under SAT. Click on that arrow there. Yep, My SAT. And then, yeah, okay, yeah, I'll give it to you. Okay, and then scroll down and you should see your practice attempts down here. Oh, you found it? Okay. Yep. Perfect. I can also give you the Wi-Fi. Let me see where it's at. Connect you. I know, isn't that cool? High tech.
Storage.
Of course it is. I know. Will it let you? Okay. Mm-hmm. Okay.
Yeah.
Perfect. All right, so on your practice test, when you go ahead and get logged in there, let's go through the questions that you got wrong.
I did look at it on my computer after I finished it. I got
Yes.
2 wrong.
Okay.
Do you remember what they were?
Okay.
One was about like text of a picture.
Mm-hmm.
There's 1 and 2.
So 8, it was number 8 and 10. Okay. So Elam, what if you're logged in there, you can go ahead and pull up your practice from last night. SAT module or practice test 6, module 2 is the one that I asked you guys to do for reading. And so we have questions 8 and 10 that we're about to go over right now. Yeah, do you have?
I did 4.
Did I say 4? Maybe I did. Oh, you know what? I did say 4 because we already went through 6. Practice test number 4. You're right. Yeah, thank you. Thank you. No, you're good. Either way, it still would have been helpful. Let me get in there. Yes. Practice test number 4. Misspoke there. Okay, module 2 for the reading. We have questions 8 and 10 so far that we need to go over. Yeah, he said the same thing. He's like, oh, I did test 4. Sorry, didn't mean to cause panic. It is module 2, test 4. Okay. Okay. So question 8, this one right here, the main purpose. Okay. So yes, this one is kind of silly. Let's take a look here. Okay, the following text is adapted from Susan Glaspell's 1912 short story, Out There. An elderly shop owner is looking at a picture that he recently acquired and hopes to sell. It did seem that the picture failed to fit in with the rest of the shop. A persuasive young fellow who claimed he was closing out his stock let the old man have it for what he called a song. It was only a little out-of-the-way store which subsisted chiefly on the framing of pictures. The old man looked around at his views of the city, his pictures of cats, his cats and dogs, his flaming bits of landscape don't belong in here, he fumed. And yet the old man was secretly proud of his acquisition. There was a hidden dignity in his scowling as he shuffled about, pondering the least ridiculous place for this picture. So I kind of get the vibe that this is like an ornery old man that's kind of a hoarder. And although he doesn't need more stuff, he got it from a young boy that was probably giving it away, and he probably couldn't resist it. That's the kind of vibe that I'm getting. He doesn't have conflicted feelings, I don't think. It says that he's secretly proud of his acquisition, but we kind of get that. To convey his resentment, he's not resenting anything. Or let's see here. Sorry, it might be A. Let me take a look at that. Convey the shop owner's. Yeah. So okay, so to convey the shop owner's resentment, he's definitely not resentful. To describe the items that the shop owner most highly prizes, it doesn't say that either. He says that he enjoys all of his paintings and stuff, trying to find out where it fits in, and then to explain differences between the new picture and other pictures in the shop. It's not that one. Now, this is the key right here. It says here, let me take a look here. So it says he fumed. Okay, they don't belong in here. He fumed. And yet the old man was secretly proud. There was a hidden dignity. So I kind of, in his scowling, so they keep bringing up like contrasting emotions. You don't have dignity when you scowl, and you don't have secretly proud is like a guilty pleasure kind of thing. And then he's fuming. It doesn't belong in here. He fumed. So I would guess that's kind of why that is talking about the main idea is it just keeps going back and forth about his space and how he's kind of proud, but at the same time, like not outwardly, like he's a little embarrassed by it maybe. Hey, how's it going? You're okay? Does that make sense?
Yeah. I mean,
Which one did you pick? What option did you pick?
Because B
Okay.
and C definitely made sense, but I thought since it said he was secretly proud, like internally there was no confliction.
I gotcha.
Like, proud.
Now, the only thing I would say about that is that the only part that he talks about the new pictures and the other pictures is this part right here. The old man looked around at his views of the city. It's that one section. The rest of it, like if you're talking about percentage wise, because for main idea stuff, I really like to think of it mathematically and how much of the passage is talking about the other pictures. Only this much, but it says frequently out of here more sentences than not, probably a third to a half of the passage is talking about his conflicted feelings. Were you able to complete the practice test for module 2? Okay. That's okay. That's not a problem. Eliam, do you have any questions on module 2? We did questions 8, and then number 10, you mentioned you already knew what you got wrong on that one.
Yeah, I picked C, but I didn't realize that it said Wisconsin and Iowa. Because for Wisconsin, it makes sense.
I gotcha.
So, yeah, I just screwed up.
Okay. So let's see. So what is it? A?
Yes.
Okay.
That's what
Okay, yeah. I gotcha. Okay. Okay, 13 is one that he got wrong on there. So let's take a look at that. Okay. And this is good too. I think we may go over this one. Let me see. No, but I've done this one before. This one actually was tricky, if I can remember correctly. I just remember this percentage situation and was like, what is happening? Okay, so we're trying to describe data from the table that supports the researcher's claim. Okay, so we have Alicia, Isabel, and Rocio recently claimed several plots within a diverse plant community in Southeast Spain. Several plots within a diverse, the researchers calculated that if individual plants were randomly distributed on this particular landscape, only about 15% would be with other plants and patches of vegetation. They counted the number of juvenile plants of 5 species growing in patches of vegetation and the number growing alone on bare ground, and compared those numbers to what would be expected if the plants were randomly distributed. Based on these results, they claim that the plants of these species that grow in close proximity to other plants gain an advantage at an early developmental stage. Now, by the way, this is actually factual. Plants do grow better. If you put 2 seeds together, they're going to help each other germinate. Now, once they grow, you have to thin them out, otherwise they'll choke each other out. Same, just like people. If you get too close together, you're like, wait a minute, I need space. So that's actually factual, which is kind of a cool thing there. Now, the researchers are claiming that if they grow in close proximity to other plants, they have an advantage at an early developmental stage. So what would help that? So remember, when we go ahead and answer this, what we want to kind of do is think through, before we look at the answer choices, we have to think through what would support this researcher's claim. Okay. If they grow in close proximity to each other, that's going to be the patches of vegetation, right? The percent found in patches of vegetation, let's see here. I think it's going to be D here. For each species, the percentage of juvenile plants growing in patches of vegetation was substantially higher, because that would support the researchers' claim that they have an early advantage. than if the plants are randomly distributed. That makes sense? Okay. Um, so anyway, when we're talking about this and we're trying to support a claim, we have to state what their claim is and kind of what they're thinking. And they're claiming that the juvenile plants is the subject there. Like that's what we have to look for in our answer. The other three choices don't really make sense as far as what the researchers are trying to claim. Now, Elam, you chose C on there. Let's see. That may be true, but it's not describing the data in a way that will support the researcher's claim. I don't know. Let's see, randomly distributed. Yeah, that's what I would say. It's just not exactly explaining what and defending what the researcher's claim is. All right, so any other questions on there? We went through 8, 10, and 13. Nothing else? Okay, today we are going to focus on math. Okay, I'm going to pull up we're still in test 4 right now. So I guess we can just stay here. That's fine. Go on test 4. Okay, I'm going to leave this up just for a second. We're not going to let that thing run out, but I do want to go over some tactics with you guys. Although sometimes it's easier, you may think it's easier to solve these things by hand, I would highly recommend using Desmos. Okay, Desmos is very user-friendly, it's very intuitive, it's right there on the screen, and you'll do yourself a service. You'll do yourself a service by using it. I'm normally not a huge calculator girl. I do not, when I taught Algebra 2 at Navarre High School, I was like, you guys are not allowed to use calculators. And my kids fought me up and down. They hated me. And I was like, I promise you that I'm doing you a favor. Mark my words, 2 years after that, they all got to college and they're texting me talking about, thank you so much. I'm the only one that knows how to do fractions and because we didn't have to use the calculator. And I was like, okay, you're welcome, I guess. So I'm normally not a calculator girl. I want to show you guys the best way to solve it. And this is going to be different for you guys. Some of these questions, I'm going to post them in a way to make you think about it. The whole test is you're going to feel like a veil has been lifted from your eyes, because I'm going to teach you how to look at these questions and be like, hello, there's only one logical answer here. Okay. For instance, we were talking about one of these questions. I don't know if it's on this one or what test it's on. Talking about a skid, a car making a skid, right? And it was asking how fast the car had to have been going. Well, one of the options was 12 miles an hour. Are you skidding at 12 miles an hour? Probably not. Okay. It's highly unlikely. So one of the students, I was like, can we eliminate any choices? And that was the only one that was like that low. And no one got it. And I was like, we all drive. I was like, do you all drive? Do we all drive in the room? And everybody was driving in the room. And I was like, have you ever skid before? No? Okay. Well, I mean, that's good, I guess, but 12 is out. 12's out. Okay, guys, we're not skidding at 12. And then the other one was like 200 and something miles an hour. And I'm like, I don't even think my car goes up that high. I'm like, if you're going that high, you're going to be on the Autobahn, probably getting pulled over. And then hopefully we still get to see you afterwards. But like 200 miles, I'm like, that doesn't make sense. So even just thinking about it like that, you have to use logic. So many students sit there and they just get calculator happy and they start typing stuff in and they arrive at an answer that happens to be shown on there. And then they pick it without even thinking through, is it logical? It doesn't make any sense. So we are going to approach this very differently. Now, the short answer questions, those you have to know how to do those, period. There's nothing, I can't help you do process of elimination. I can't tell you how to guess on those. It is what it is. So on those, you're gonna have to pay attention and really invest time. I would save those. I would do it one of two ways, and you can pick knowing yourselves best. You can either answer them first, get them out of the way, so that you know that you can at least have a chance to answer all the multiple choice ones, or you can save them until the very end, putting all your effort into making sure the multiple choice are correct. I would not do them in order. Okay. Yeah, it's just not a smart thing to do. You're going to waste too much time perhaps on one question or another, and it's not an effective use of time. Okay, now here's another strategy. I recommend that you only spend about 15 seconds on the first 12 to 15 questions total. Okay, so like 15 seconds per question for the first up to 15 on both. Okay, for math. Now, that might sound like, how in the heck am I going to solve a math problem in 15 seconds? I promise you that some of these questions, they take seconds, like 2 seconds. Okay. One of them, I think it was so stupid. I think it was like 3579. What are the next three numbers in the pattern? And I was like,
I know they give you one like exponent.
Yeah. Yeah. Where you just type it in. Like, it takes literally 2 seconds. Okay. So when I say 15 seconds, I'm talking 1 Mississippi, 2 Mississippi, 3 Mississippi, all the way to 15. You get a minute per question. Okay. Just over a minute per question. But if you can save time in the beginning when it's easier, you're going to set yourself up for success when you get to the middle section. You're going to start to feel some tension build in there. We were talking about lifting weights the other day. When you add on that next set, you're feeling some tension. You're going to shake a little bit, okay? Weighted push-ups. Yeah, he said, dang, 15 seconds is fast. Weighted push-ups is a real thing. Like, put some weight on your back, and then you go ahead and throw on another 25, and you're like, wait a minute. That's how it's going to feel. When you get to question 12 to 15 on this, you're going to be like, oh, shoot, this is, okay, all right. All right, increasing the pressure now. Then when you get to the back third, buckle up. Okay, that's when things are going to start to get a little turbulent. Get to the second module, same thing, except you're starting off hopefully at a level that's even a little bit harder than where you started module 1. So it's already starting here, and it's going to increase in difficulty as you go. Okay, so with all that being said, see, like this, okay? If x is 7, what is the value of x plus 20? I wonder. Okay, it is 27. Okay, we just plug in 7 for x, 7 plus 20, 27. Okay, by the way, if you guys have any questions, I am not meaning to sound like condescending if some of these just seem very easy to me. They are easy to me, but I'm not meaning to sound condescending. So if you have questions, please ask. I'm never going to make you feel stupid, unless it really is like a stupid question. Then I might laugh at you a little bit, and then we'll get through it together. No, I'm totally kidding. But like the seriously, the 357 question, I was like, if anybody gets this wrong, I'm coming after you. That's how I felt there. Okay, now this one is one of the ones that students will look at and immediately hop over to the calculator. But for why? Why? The first 4 numbers in both data sets are exactly the same, right? In the second data set, you're adding in a higher number. So what's going to happen to your mean? You don't have to calculate that. If you want to, you can, but it's kind of a waste of time. So the mean of data set X is going to be less than the mean of data set Y. And we haven't touched a calculator. We have not had a brain aneurysm, nothing like that. Okay, think about this in terms of your grades. Okay, you get 4 identical grades in 2 classes, and then you get one that's significantly higher. 27 is in this perspective is significantly higher than all the other numbers, and you get that grade in that other class. Your average is going to increase. Okay, so think logically about these things, and it's really going to do you a service when you get here. Okay, Right triangles, PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18, what is the measure of angle S? Okay, this one requires a little bit of math. On here, it tells you right here at the very bottom, the sum of the measures in degrees of the angles of a triangle is 180. Okay, so you don't have to remember that. It's right there. So if we know that there's 180 in each of them, how do I solve this? Close. So it's going to be 180. We're going to start there. And what do I do with my 90 and 18? You're going to subtract them. Okay, so the answer is 72. Now, you might ask, well, how do we know that? If we are solving PQR, how do we know that STU is the same? The beautiful thing about similar triangles is that their angles are identical. Okay, so their side lengths are not. You can clearly see that the STU is smaller than the PQR, but their angles are actually identical. Okay, angles don't change. Like if I were to hold my hand like this and I were to slice it here, this is smaller than if I were to slice it here. But have I moved my finger at all? No, that's what's happening here. Okay, you're just extending. Q is a little bit further down the line than T is on there. Okay. And I will give you guys an opportunity to answer some of these, especially in module 2. I want you guys to practice being fast on the first several. Okay. A rocket contained 467 kilograms of propellant before launch. Exactly 21 seconds after launch, 362,105 kilograms of this propellant remained. On average, how much propellant did the rocket burn each second after launch? Okay. Now again, we need to think logically about this. 21 seconds, we've lost 105-ish, right? So which option is not possible? D. Okay, please don't pick D. We're going to need that number though. It's that number divided by 21. Okay, so which, if you had to guess, what would you say? Okay, you can even estimate. If I make that 5,000 and I multiply it by 20 instead of 21, what am I getting? 100,000. Right there. Okay. I'm actually not even going to use the calculator because the other ones are so far off that it's not like you've got 4995, 4996, 4997. It's not like that. These are like way far apart. So if you think logically, you're burning about 5,000 kilograms of propellant each second. You can fact check yourself. 5,000 times 21, and that needs to be 105, okay, which is very close. I wish I could crack my neck like that. Wish. There's a chiropractor over here in this thing. His name is Dr. Marshall. Oh my God. He does such a good job, dude. He sits there and he like talks to you while he's getting your neck ready, and you can feel it. Like you feel it kind of lock in, and then he just like and then he sits there. I know. It is kind of scary. I'm not gonna lie.
I want to try it.
Oh, you just did it.
Well, yeah, but like best.
You should. It's the best feeling ever. And you do both. He does both sides. So like yes, it's kind of like cracking your knuckles, but it's like better. Anyway, so jealous. I had back surgery in 2019, and so I've been like rehabbing through working out and all this stuff. Anyway, and he was helping me with like my recovery and everything of how to properly crack my neck, and I cannot crack my back or my neck since I had surgery. So now I've got to pay him for it. Maybe that's what he did. He made me have surgery, so I'd have to continue to pay him to crack my back. I know, what a scam. Okay, so for this one, you may actually be able to do this in your head, but based on my experience, students that try to do this stuff in their head make stupid mistakes. Really, really, really stupid mistakes. So I'm going to show you, even though this doesn't seem like it's super hard, I'm going to show you how to do it in Desmos. Okay, all we're going to do is type in 4x equals 20 and negative 3x plus y equals negative 7. Okay, all I did was type in exactly what's given. It's asking for the solution. So I put my finger right there, boom, it pops it out to me, 5/8. Now, it's asking though, what is the value of x plus y? So you've got to read, okay? It's going to be 5 plus 8, which is 13. Okay. Now, if you wanted to solve this by hand, you could. I'm not going to say not to. In the first equation, all you'd have to do is divide both sides by 4, and then you're going to get x equals 5. So you know that side of it, but the part where I've watched really, really, really smart students make very stupid mistakes is they'll go plug it in, get negative 15 plus y equals negative 7, and then they do some sort of calculation error in there. And the SAT, now in this case, they're actually being nice with the answer choices, because even if you plug in 15 and do some calculations incorrectly, you're not going to get one of the answers on there. Like, it's not going to show up. Sometimes they'll work the problems out incorrectly and make those answer choices. So you have to be on your game when it comes to this. Okay, here's one that is a short answer. So what I'm going to do is I'm going to flag it and come back to it. Okay, we're not going to spend time on the short answers yet. And now, granted, it might be that particular one is actually a pretty fast question to answer. I just don't want you having to risk missing out on a multiple choice question because you spent too long contemplating how to do that one. Okay. So here's one. Okay, square x has a side length of 12 centimeters. The perimeter of square y is 2 times the perimeter of square x. What is the length in centimeters of one side of square y? Okay, it is D. Mm-hmm. It is 12 times 2. Yeah. So if you were to go through and solve it, you would find out that it's still 24. Okay, but in this case, now the reason why this works, let me not just like tell you that it's the answer. I'm going to tell you why it works. Side length and perimeter are the same constant. How do I say that? Like the, yes, thank you. That's the word, proportional. When you're doing area, though, it's the square of that. So area is a little bit different. Perimeter is just, it increases the same amount as the side length, okay? 24. All right, this one here. So it says the given function G models the number of gallons of gas that remain from a full tank of gas in a car after driving M miles. Okay, let's process that for a second. In this equation, we have a negative slope. So what does that negative mean? Right, it's being consumed, but specifically that negative 0.05, what is that? Yeah, it is the slope. It's the amount of gas that's being consumed per mile. Okay, which is very important as we get to this question. According to the model, about how many gallons of gas are used to drive each mile? Okay, so many of my students, they panic. They'll pick 12.1, or they'll try to add those together. I don't even know where 242 would come from. But you've got to think through this, and then I have students say, well, the 0.05 is not negative. Well, yeah, because you're not burning negative gas. Like it, so you've got to think through this a little bit. It's so obvious. The answer is so painfully obvious that we tend to overthink and think that the SAT can't possibly be this easy. It is. Okay, we are on question 8 so far, and we have not really done any math yet. We've just been thinking through it. Okay, right here. So if this is another short answer, this one I would say do it on Desmos, but we'll get to that after. Okay. Here's a literal equation. So the given equation relates the positive numbers bx and y. Which equation it correctly expresses x in terms of b and y? So what does that question mean? Right. Now, you can look at your answer choices and see that, right? We're solving for X. We want to get B and Y on the other side. So what is the step here that we need to do, or steps, to get X by itself?
Multiply by y.
Good. We are going to multiply by Y because it's currently divided on that right side. Okay, and I can write this out as well. Let me open our thing here. When we're solving a literal equation, we want to think of inverse operations. Okay. So we have 1 over 7b. I think it was 11 x over y, yeah. Okay. So we have to think through inverse operations. Currently, this is divided. So we're going to multiply everything by y. When we multiply this right side by y, it's just going to cancel out that denominator. And then on the on the left side, it's going to be y over 7b equals 11x. From here, we divide both sides by 11, which is really just going to end up down here, okay, with this guy. So it's going to be y over 77b equals x. Now, at the very minimum, okay, you can see we are not going to be adding or subtracting anything. So for the love that is all good and decent, do not pick B. Anything else would be plausible, but don't pick B. Also, 7b being in the denominator is a big help there. Okay, we are not touching the 1 over 7b at all, which means these two are not possible options. B has to stay in the denominator. In both A and D, B is not in the denominator anymore. So we can eliminate those. Another way to do this is that you can pick a value for B. I wouldn't necessarily recommend doing that, and then you can type it into Desmos and see which graph is the same. Okay, so if you get stuck, that is like the last way that I'd recommend to do that. Okay, this is question 11 here. So right about here, another one. Okay, starting at 13, you're going to notice that it's going to increase in difficulty a little bit. Okay, now let's see, the point x 53 is a solution to the system of equalities in the xy plane. Which of the following could be the value of x? How would you guys think to solve this initially? Any ideas?
Y is 50
Mm-hmm.
and less than x would have.
Negative, right?
Oh yeah, that's
Yeah, it's got to be negative. So we can eliminate those two.
4 times 5. Yes.
Right. So -9, let's try that. So we've got -36 plus, yeah, it's got to be A. Okay. So good. That was a good process of elimination. Now, I understand what you're saying. I don't know that that would be super intuitive to everybody, though, is to think through it. For you, that works wonderfully. Algebraically, that is actually how you do it algebraically. You plug it in, and no problem. What I would say, even if you can work it out algebraically like you just did, so great job, I would recommend still put it into Desmos. Okay, does not hurt to get a visual on it, just to check and make sure that you're correct. I was working with a student this morning, and he said, I've never once gone through and changed my answer. after going back and checking it. He's like, I just trust that when I'm in the test, I'm going to make the best decision that I can at that time. And then when I go back through it, I'm not going to change answers. And I was like, all right, buddy. I'm like, so we've got work to do because you haven't hit a 36 yet. I think he's doing ACT. I was like, you haven't hit a 36 yet. So you've got to change some answers. Like, I love the fact that you're so confident. What happens though is if you answer it algebraically, I would recommend checking it a different way. Vice versa too. If you solve it graphically, go through and make sure that it makes sense algebraically. Okay, have a double check for yourself, and then your scores will increase quite a bit. Now we have the y value of 53. Okay, so that's going to be all the way up here. Okay, you guys can see three colors on the screen. The black is for the second inequality down here. The purple is for the upper equation. That overlap is going to be the solution set. That is where we are looking for. Okay, what I'm going to do is type in one more equation, y equals 53. The reason I'm doing that is it will help us know, okay, it'll help us know what has to be over to the left of it. We can see here that this is negative 8.75, and that's on the line of our graph. We can't have it on the line. It has to be in the solution set, which means it has to be negative 9. It's got to be to the left of negative 8.75. Okay. Does that make sense? Okay. Now, as we're going through this, like I said, ask away. Happy to ask questions, answer questions. Okay, this one was a little tricky. So already, just between the last one and this one, question 13 and 14, I told you that it was going to get harder, okay, and it does. Bacteria are growing in a liquid growth medium. Gross. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubles every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? If you had to take a guess, what would you say? If it's doubling every 3 hours and we're doing 15 hours after the initial observation. I don't think it's going to be A. Okay.
I would say C.
Okay.
Well,
D? Okay. What do you think?
yeah, I think
Okay. So the way that I do this, I write it out. I know that might sound like time consuming, but mathematically, I think it's going to make the most sense that way. The answer is D. But I'm going to show you guys how I work this out just so you can, have some perspective there. Okay. Initial observation. So we're going to call that 0. We have 300,000. We're collecting it every 3 hours for 15 hours. Okay. So we have 3, 6, 9, 12, 15. The first observation, it's going to double. Let's see here. So we've got, let me make sure my math is right here. 1.2. Fifteen hours after the initial observation. Wait, I remember there being, is that one doubles every 3 hours? So 3, 6, 9, 12. I remember there being a trick on this one. Yeah, because it's not 72. Hold on. Do you guys see an error on here somewhere? Let me write all this out. Hold on. Every time I do this one, I remember it being tricky. This one is doubling every 3 hours. So when we observe it at 3, 15 hours after the initial observation, this is going to be 600,000. This would be, if we need to, we'll come back to this one because I know that it's something simple. This one would be, 48. Yeah, I don't know. My math was wrong somewhere, but here it is, 96. I don't know what I had written down before. Anyway.
Oh, you put 36 and 12.
Thanks. I knew I made an error somewhere. I was like, I don't see it. Okay. That's why I said, let me just write it out because it's, anyway. Yeah, so good, Elam. I saw your answer too. It's D. Okay, I just write this out every time. The first time I did it, though, I had written my 3 here by my 300,000. I don't know why, but an initial observation means that's what you're starting with, obviously. Okay, so 96 there. Okay, interpretation here. Okay, or not. Let's get this thing here. Okay, this is an exponential graph. I'm not sure what is going on here. There we go. Maybe. Okay. The graph gives the estimated number of catalogs Y in thousands a company sent to its customers at the end of each year, where X represents the number of years since the end of 1992, where X is between 0 and 10. Which statement is the best interpretation of the Y-intercept in this context? Okay, so think about this. Catalogs, you guys probably don't even know what catalogs are. They were books, okay, that they used to send out. And that's how we would pick Christmas gifts and all that kind of stuff.
The Sears catalog.
Yes.
Yeah.
All the things. Auto Trader, all that. Not, yeah. Sears, JCPenney, all that. So since the end of 1992, it's obviously decreased, right? They've put in more marketing towards digital marketing for social media, that kind of thing. Now, it says since the end of 1992, what the y-intercept, it's up there at the 9. Okay, what is the best interpretation of that in this context? Now, I'm intentionally not revealing all of the answers because I want you guys to think through this.
That would just be the amount of catalogs at the end of the
Yeah. Okay, so think through it before you go to the answers. Okay, it's D. But again, a lot of the times we get presented with options and our brain is like, oh, okay, let's look at option A. Oh, well, maybe that one's right. Okay, let's go to option B. And then we're just sitting here wasting so much time. Okay, not needed for that. Okay, which expression is equivalent? Okay, this one. You may know this off the top. If you do, great. If you don't, there is a solution to do this. Okay, any ideas on how to do this one? Okay.
it would just be
Yes, it's B. The index of our radical, which is the 7, becomes the denominator of our exponent. Now, let's just say you didn't know how to do that. You come over here, and it kind of feels like cheating, honestly. Then you click this AB button. It's going to give you an exponent there. And you're going to do 9 over 7. Come on. Why is it not? There we go. Get in there. 9 over 7. Okay. Oh. Now, in order for this to produce a graph, you have to make it equal to something. Okay, so I put equals 0 there. Here, let me see. Actually, I'm not sure if you can do a different root on here. Ah, there we go. Okay, we have the seventh root of x to the ninth. Come on, man. This thing is giving me issues today. X to the ninth, y to the ninth. Okay, equals 0. Get out of that, equals 0. Okay, now you can see that my blue line became a green line. Okay, that might not seem significant, but that means that they overlap. That means that those two things are the same. Let me show you what it would look like if it were not the same. I'm going to plug in option A here. That one didn't work. Hold on. Because I'm probably picking 0. That's why. Okay, let's see. Are they all just overlapping? Oh, because, okay, I'm picking all numbers that are like perfect even roots. That's why. Okay. Okay. Sorry, I was like, I'm not proving my point here. 0 doesn't work, 1 doesn't work. Pick a different number other than that. Okay, you set it equal to something else. You can see that I have two distinct lines. The green one is indistinguishable from the blue. I'll change this so that you guys can see. That's blue. And then I'm putting in a 2 here and it turns green. It's on top, right on top of each other. The other one down here is purple. That one is separate. Okay, does that make sense? Okay. Sorry, normally it works when you set it equal to 0. This particular one does not work because it's exponential the way that it is, but okay, good. Now the rule for that, just to clarify, yeah, the rule for that, you have an index, that's going to become the denominator. That's the easiest rule to just recall, but if you can't recall that, you can still do it graphically, okay, and get to the answer. Okay, a population of city A increased by 7% from 2015 to 2016. If the 2016 population is K times the 2015 population, what's the value of K? It is C. But why? Exactly. That's a great explanation. Okay, it's increasing. So A and B are out. Remember that increasing has to be greater than 1. Okay, you have to include 100% of 2015 plus the 7% increase, which is going to give you 1.07. The difference between C and D is that D is 70% up, which we're not saying that. Okay, 7%. That would be like rabbits. Okay, population increasing, 70% increase. All right, which of this following systems of linear equations has no solution? What does it mean to not have a solution? They don't cross, which means what kind of lines are they? Parallel lines. How do we know what a parallel line is? Let's say you didn't know that. It's fine. Take this over to Desmos and type in your options. X equals 3, y equals 5. That you're asking yourself, do these lines intersect? Yes, they intersect, so it's not A. Then you go to B, then you go to C. When you get to C, you will see parallel lines that will not intersect. Okay, good. Questions like these tend to be a little tricky for students. Okay, the first term of a sequence is 9. Each term after the first is 4 times the preceding term. If W represents the nth term of the sequence, which equation gives W in terms of n? Why is it D?
Because it has 4 being
Before it? Prior to it. Okay. Now, D is correct. Okay. The first term after the equal sign is always the starting term. Okay. It doesn't matter what context this is in. So if we're talking about the value of a car when you first buy it, the initial investment into a bank, the first number that you're talking about of a sequence, it doesn't matter what it is, that's always going to be your starting amount, your principal amount. Okay, so good. 9. Whatever the base is, it's going to be, like you said, manipulated by that. It's going to be increasing by that, okay, by that quantity each time. The easiest way I think to do this is to pick like the first, second, and third term of n and just work it out, okay? You guys are smart enough to know that the first term is 9. And so the second term is 4 times 9, which is going to be 36. The third term would be whatever that math is, 9, or let's see, 4 times the previous one, 4 times 36. Okay, we're looking at 204, something like that. I think that's way off. 144? Something like that. 1 something 4. So you guys can actually figure this out. Okay, mathematically, if we plug in a 2 for n, the second term of the sequence, 2 minus 1 is 1. 4 to the first power is 4. 9 times 4 is 36. Okay, so you can figure this out without actually knowing what a sequence is and how you raise your exponents and all that. Okay, any questions there? Okay, this module is going to come to a close here on us, which is fine. I'm not too concerned about that. Yeah, of course. Yeah. Like you're talking about the short answer ones? Yeah. Because they're all kind of, I'm just going to let this timer run. Or I can click next. We'll go to the next one. Now, you notice really, other than 1, 2, 3, 4, 5, 6, 7 of the questions, okay, there was one other short answer one. All of them were relatively simple. Like, we didn't have to overthink them. We didn't have to write down a lot of answers. We really thought logically about them, which is great. Okay, even some of the short answer ones that were on there are actually not that hard. I just don't recommend spending all of your time on them to start. So let's go through one of the short answer. We'll start with the short answer ones on module 2. I can already tell, yeah, it's just increased quite a bit. Okay, here's one. In the given equation, k and n are constants and n is greater than 1. The equation has no solution. What is the value, bless you, what is the value of k? This one, I think you guys will be surprised at how to solve this one. Ish. You'd have to pick a value for k, or you'd have to pick a value for I don't know if you can actually, because you don't have y and you don't have k and you don't have n, so you have too many unknowns in this one. Any ideas? Okay, let me ask you in a different way. What does it mean to not have a solution in this case? No, it means that they don't intersect. Okay, so if we think about the left side of the equal sign and the right side of the equal sign as two different entities, and if they don't intersect, then they're parallel, which means what about their slope?
Oh, I see what it is. K is half of -28 over
Mm-hmm.
half of
Now, the y-intercept is going to be different,
Oh, yeah,
right? But the slope, that you're exactly right. Okay, so this is how we're doing this. Okay, this one is a little sneaky because I don't think it's very obvious that they want you to view these as two separate equations. Right, so I'm going to write this out actually, if I can get my screen to split properly. Let's do this over here. Why is it not? Okay. Someday it will do what I needed to do here. Please eat. Please eat. Eating is always a great thing. Okay. Gotta get the gains, man. What do you say? Oh, leg day. Never skip leg day, bro. I did leg day Monday. We were doing deadlifts. And last night I'm laying there and I shrugged my shoulders and I was like, oh my God. I was like, what did we work out? My husband was like, he's grabbed my traps as hard as he could. You're such a dick fan. I was like, oh my God. Yeah, anyway. So yeah, never skip leg day, bro. Can have, little seagull legs and big biceps. All right. But my husband is 6'2" and I'm only 5'2". So my deadlift, especially like my sumo deadlift, is a whole like 3 inches off the ground. He's like, eager, eager. I'm like, you shut up. Like, but it always feels so high for me. Like I'm just short. So when I'm pulling weight, like my deadlift is high. I mean, I can lift over 300 pounds on that thing. That's some muscles. And so I feel like I'm climbing Mount Everest, but when I look at it from a video, it's hysterical. It's literally like this high off the ground. And I'm like, whatever. I'm proud of myself anyway. Okay, so sorry, back to this, a little detour. We're going to distribute this 2. Okay, so we have 2kx minus 2n equals -28 over 15x minus 36 over 19. This is the trick here. They're telling you that this is one equation. This is the second equation. And since there's no solution, the slopes are the same. In other words, 2k equals -28 over 15. And in order to solve this, we would just divide both sides by 2, or same thing as multiply by a half. Now, one of the tricks that I like to teach about fractions is that order of operations, when you're multiplying by a fraction, you can just cross simplify first. There's nothing that says that you have to multiply straight across first. So I like to divide and simplify my terms that are across from each other first. So k is going to be -14 over 15. And that's our answer. Okay, that one was a little bit tricky and required some thought. Hence why I like to flag these and not solve them first. Okay, there is no way that under pressure on module 2 that you guys are going to be logically thinking through this and be able to answer it in a quick amount of time. Okay, it is not worth missing the other ones for that. Okay, here's another one. A gift shop buys souvenirs at a wholesale price of $7 each and resells them at a retail price that is 290% of the wholesale price. At the end of the season, any remaining souvenirs are marked at a discounted price that is 80% off of the retail price. So, what is the discounted price of each remaining souvenir in dollars? Pull up the good old calc here. All right. We're buying it for $7. Okay. Marking it up at a retail price that is 290% of the wholesale price. So we multiply 7. Oh, even check this out. 290% of, it even writes it there for you. That's crazy. Of 7. Okay, so $20.30 is what the gift shop is selling it for. Now, if it's a discounted price that is 80% off of the retail price, how much are we actually paying? If it's 80% off, what's the other percentage? 20%. I like to do 80% off as subtracting it and figuring out what that other part is. It makes your math a little bit easier. Okay, so if it's 80% off, you're only paying 20% of the retail price. So you can do 20% of our 20.3. Okay, so the discounted price of each remaining souvenir in dollars is going to be $4.06. 0.2.
Can I use that trash can?
Yeah. $4.06 there. All right, here's another one. Okay, these ones are getting chunked together all in a row. If in the given equation C is a constant, the equation has no real solutions if C is greater than n. What is the least possible value of n?
Does it say that it does 0?
That is correct. In this case, graphically, the parabola would be off of the x-axis.
So it's just asking.
Now, we do have an option here. We could go over here. If I can get this thing, there we go. Something weird happened with when I was resizing this, and it is not being my friend right now.
Yeah, I use the bathroom.
Sure, yeah. All right, we're just gonna type in, I'm gonna try x squared. Okay, it looks like it's working here, 34x. Okay, I'm trying to get it, there we go. Okay, do you see how low this is going? Right. Oh, you know what? Hold on. I need to type in y equals. There we go. Okay, that's going to change it a little bit. I was like, why is it so low? Okay, so you see it's all the way down here. I can play with this a little bit, and I can try, since negative 289 was there, what if I do plus 289? Now, here's food for thought. Can it be one solution based on our question? No. So the very least value would have to be 288. Okay. Or 290. What was the thing there? 289. If we do no, it has to be strictly greater than 289. Yeah, not equal to, but strictly greater than. So 289 is fine. Because it cannot be 289. But based on our problem, it says C has to be greater than N. So if C is 290.
Oh, yeah, that makes sense. It could also be like 289.1.
Yeah. But you see, anything that's right off of the x-axis, we're good to go. Okay. Now, there actually is a way to solve this algebraically, okay, and that involves the discriminant, b squared minus 4ac. I don't know that it's particularly easier though. So just to kind of recap that, okay, no real solutions means that the graph does not cross the x-axis. So we graphed it first, just y equals x squared minus 34x, and felt what it looks like and where it hit, where the vertex is. So the vertex is 289 there, and it just has to be greater than that, okay, in order for it not to hit the x-axis. Okay, this one has another one. These are all in a row, which is interesting. I don't normally see this way. All right, data set A consists of the heights of 75 buildings and has a mean of 32 meters. Data set B consists of the heights of 50 buildings and has a mean of 62 meters. Data set C consists of the heights of the 125 buildings from data sets A and B. What is the mean in meters of data set C? That's a little tricky. And I'm going to scoot this over a little bit so I can write. Okay. How do we find mean of something? The mean of something. Exactly. Now, Desmos makes this super easy for us, by the way. If you're ever asked to find the mean, all you have to do is type in the word mean. It's kind of crazy. So on here, I guess I always do it on this one. You type in the word mean, parentheses, and then you just do 5, comma, whatever, and it will calculate it for you. So yeah, Desmos is wild. Okay. So you know that we have to add up together some of the heights of the buildings and divide it by the number of buildings. So in this case, we know that data set A has the heights of 75 buildings. So the mean is going to be okay, and then B. The mean is going to be the same thing. It's going to be the sum of the heights. Okay. Then we've got C, which is going to include the number from A and B. It consists of the heights, and we're looking for the mean. So for the first one, for A, the mean is 32. We know that the sum, we don't know the sum, and the number of buildings is going to be 75. For data set B, we know that the mean is 62. We don't know the sum, but we know that the number of buildings is going to be 50. How would we find the sum of these two right here? This one and this one. Right. We're just going to multiply by what is currently divided by. Okay, so 32 times 75 and 62 times 50 here. Okay, 2,400 and 3,100 is what I'm getting. Okay. I just really need for this to do what I needed to do. Okay. 2,400 and 3,100. So now we can add those two up and put them here. This is going to be 5,500 because it's the sum of both data sets A and B. That's what C is. So 5,500 divided by 125. Okay, it's going to be 44. That can't be right. A mean, 32 and 62. Yeah, 44. Okay. I was reading 75 and 125. I was like, that's not logical. Okay. Does that make sense in there? Okay. So just to recap that, they gave us two data sets and they gave us the mean of both. We had to figure out the sum in order to figure out the sum to put into C, which involves both data sets A and B. Okay, and then solving inverse operations, that kind of thing. Okay, those are some of the word problems in module 2. So these are going to be, these are challenging, right? This one is significantly different than the first one. First one, we flew through it. Didn't really have to do a lot of math. Module 2, we've had to do quite a bit of thinking. This is the higher level math in here. And just remember, so tomorrow we're also going to dig through the higher level, like the really hard ones, some trig, that kind of stuff. For today, my goal is to get through the modules to show you guys some of the different ways to approach these problems. But I do want you guys to get some practice on here too, okay, to see how you do. Hello again. A long time no see again. Oh, wow. In the given system of equations, A is a positive constant. Okay, the system has exactly one distinct real solution. What is the value of A? What do you guys think for this one? We have a quadratic and then a line, and there's only one real solution.
So, give it half.
Y is negative 1.5.
X. Because A is the y-intercept, so at 0, A is negative 1 cross.
Yeah, I didn't think about it that way. Well, A is a positive constant, though. A is positive. Mm-hmm. I'm just trying to think, because you're right. Well, no. A is not the vertex. A is the y-intercept. Is that what you said?
Yeah, but
okay.
At 0, it would be.
Unless it's shifted. In this case, I think it actually is shifted. This is going to be, because negative b over 2a is the x value of the vertex. It's going to be at negative 4. Negative b over 2a, yeah. It's going to be at negative 4. So the vertex, yes, that would work if it were centered at the origin. In this case, it's not. But knowing that we only have one really unknown variable, we have our y already. We're missing x, but we have to have an input. So we're really only missing a. And it only has one distinct real solution. So let's take a look at this. If we take this and we say negative 1.5, so I'm just replacing that y value in there, equals x squared plus 8x. Let's try 3. Okay. No, you know what? I don't like that, the way that that's happening. Let me try. Do I? I don't like guessing for A. We can do that, but it doesn't say that A, it does say it's a positive constant, but it doesn't tell us even where to start. And there's an infinite amount of numbers that we could try. I don't think we're going to be able to do y this way. I would solve it by factoring, doing it by hand. No, I would actually do it the discriminant. Okay, let's dial back here. So we have y equals, this will give me issues, maybe it won't. Let's see that, okay. All right, we have y equals negative 1.5. We have y equals x squared plus 8x plus a. This part right here goes into y. We've got negative 1.5 equals x squared plus 8x plus a. So this is how I would solve this. I would add this over to both sides, and then I would use the discriminant. Okay, are you guys familiar with the discriminant? No? The quadratic formula, it's the part in the quadratic formula that's under the radical, b squared minus 4ac. If it has no or one real solution, that means that the discriminant is going to be equal to 0. Now, when we're filling out the discriminant, the value in front of x squared is a. That's going to be 1. The value in front of the x is b. And c in this case is actually both of those. It's going to be a plus 1.5. But you see, by doing this, we now can solve for a. So it's going to be 64 minus 4 times a plus 1.5 equals 0. Going to distribute this. And hopefully it's making sense to you guys as to why I said to skip these. Initially, anyway. Because these are tricky. 64 minus 6 is going to be 58. So negative 4a. We're going to subtract 58. $14.5. That was way too hard for what it was worth. Okay. So in this particular case, I would just suggest to flag this and come back to it. I don't think, to my knowledge, there's not an easier way to solve this. I would suggest verifying that your answer is correct, always, if you can. So this is going to be, okay, we got this 14.5, and then this would be y equals negative 1.5. And you can see that they intersect exactly at one point. But we have to figure out what a is. So to my knowledge, there's not an easier way to solve this. I would not waste your time on a question like that. Okay?
They give you the reference for that?
A great question. I am not aware of the discriminant or quadratic formula being on here. The reference sheet is more like a banner that they wave, where it's like, we gave you guys a reference sheet, and it has nothing on it that you need. Like, they do give you, yes, they give you the 180 degrees in a triangle, they give you the volume formula, but have we needed any of them yet so far? So not very helpful. Okay, and also, so the reason I started to say you might be able to guess at what a is, this is a prime example where that's not really effective, because who's going to be guessing 14.5? Nobody. Okay. Okay, this is another one that you guys may have a little bit of trouble with. Hopefully, after I explain this, you'll be like, oh, duh. Or you might just get it on top. You might just get it already. But the dot plot represents the 15 values in dataset A. Dataset B is created by adding 56 to each of the values in dataset A. Which of the following correctly compares, excuse me, the medians and ranges of the datasets A and B? Okay. And you may be surprised to hear that there is no work needed for this one at all. 0. Okay, the median of dataset B is greater, and the range is equal. Yes, that is correct. Okay. If we're simply just changing the numbers underneath, the dots stay in the same places. That means it's identical, 2 identical spreads of data. That means whatever the median is going to fall in that middle dot, okay? If we're adding 56 to each value, the median is clearly going to be greater than the one that we have that's lower, than the original one. That's 56 less than what we're adding to it. The range, we have 22 to 26. That's only 4 values. 26 minus 22 is 4. Okay, or 4 sections in between that. If we add 56 to that, we're going to have 78 all the way up to 82. That's still only 4 values. Okay, so the range is the same. The median of dataset B is bigger than dataset A. Any questions on that? No. Okay, we're getting now towards the end of module 2, which is really good. And then we'll go back to the beginning if we have time, and I want to give you guys an opportunity to solve some of these. I mean, if we have time, like the clock on the top, we still have time in the class, and I will give you guys time to solve some of these on your own. Okay, the rational function f is defined by an equation in the form shown where a and b is constants. The partial graph of y equals f of x is shown. If g of x is f of x plus 4, which equation could define function g? I'm trying to zoom out a little bit, but sounded a little bit like a headache. That's a good question. A rational function is going to have a second tail, probably in quadrant 1 or 2. So it's going to look, if I could, like this, there will be another part of it.
Yeah,
Okay.
So it's just showing how.
Correct. Mm-hmm. Any clue? The way that I would think I would solve this, I would use some of the points that are given on the graph. You can see that some of these, some of that line goes directly through some points. I think what I would do is create a system of equations in there to solve for A and B, and then go back through and do x plus 4 on top of that. Now, I'm trying to see if there's an easier way to do this. I do think that there's an easier way to do this. Let's try this. Let's start with our answer choices. Okay, and I'm going to do 6. Okay, y equals 6. Oh my gosh, 6 over x. does this graph look like my graph? Okay. To what degree though? Like, does it look very, very, actually, yeah, if I zoom in, see if I can, I'm trying to get it like in the same window so we have an accurate picture. It's not going to be perfect, but is it close enough to be identical? That's the question. I don't think so. Because looking at the problem, it's what that x plus 4 says is that we're just shifting our graph to the left 4. So it has to be identical to the one that we're given. It's just going to be shifted. So I think this is probably the easiest way to do this. Okay, what about this one? It actually might be the graph. At -10, yeah, this could be it there because we're at, yeah, -3, -6. Yeah, that is the graph.
What we're looking for when it's shared.
Correct. So it's got to be C. Because if this, so basically this would be like that, right? X plus 4 plus 4 shifted to the left. So x plus 8 would just be shifting that over. I would say it would have to be G. I mean, excuse me, C. G of x equals 6 over x plus 8. I would say that would have to be the easiest way to do this. The only other way to do it algebraically is going to be a system of equations where you use two of the points from your original graph, plug that into the function that's given, this one, solve for a and b, and then go back and transform that graph to the left 4. Okay. You don't have time for that. So that's why I started thinking like there has to be an easier way to do this. So I went to the answer choices and started plugging that in. Hey, okay. Went to our answer choices, plugged it in to see which one could be shifted to the left 4 from our original graph. Okay, this one is all done. So I'm going to go to another practice test in here, but just to recap kind of this module 2 situation. So we worked through all of the short, or most of the short answer ones. I think all of them on module 2. And we noticed pretty quickly the tension increase from module 1 to module 2. Okay, so just mentally prepare yourself and know that that's coming. Okay, don't act surprised when you get to module 2 and it's suddenly a lot harder. Expect that instead. Now, as far as the short answer goes, I still would recommend not answering those first. Okay, on module 2, they got significantly harder and required a lot more brain power. So only solve those when you have time, okay? Or if you know yourself well and you know that your brain's going to work well that way, solve those first and then go through and knock out all the short answer ones. But don't try to do them in order because you will get stuck inevitably. And then you'll lose track of time and then you start panicking where you just choose whatever answers. Okay, let's go over, you guys did 4, we also just went through 4. Let's do practice test 5 now on here. And what I want to do is give you guys an opportunity to answer some of these, okay? I'm going to set timers for 15 seconds and see if you guys can answer the questions in the first 15 questions-ish within 15 seconds, okay? Not this one. Now, I can get you paper if you need it and a pencil. Let's see. Do either of you guys think you'll need that? Paper, pencil? Okay, or dry erase, either one. Okay. Yes, so you're good. Okay. There you go, sir. And calculator if you need it. It's a little, not a graphing one, but Oh yeah, perfect. Did you get charged up? All right, there you go, man. Almost nothing better than a phone. Do you need to charge yours? Yeah, let's do it. Do you have a lightning or a USB-C? Lightning, perfect. There you go, sir. All right, so I'm gonna set timers, okay, just so you guys can see how ridiculously long 15 seconds feels like on some of these. All right. So I'm going to click resume testing. So the question's going to pop up and then I'm going to start the timer for 15 seconds. I promise you guys are going to be like, answer real quick. Okay. All right, here we go. D. Good. Oh yeah, you guys can call it out. If you got it before that, feel free to call it out. I was like, uh-oh, we're skating here, 15 seconds. But still, okay, so 15 seconds, you're still able to solve it within that time frame, right? You don't have to be any faster than 15, but you don't want to be much over that. Good, and Elam also said D. Okay, let's go to the second one. We're going to do the same thing. Okay, test taking strategy, real quick. You can save yourself a few seconds. What is 9 times 6? 54. So you know the ones digit has to be a 4. Yeah. Okay. So you don't even really care about the other value. If the only one that has a 4 in the ones place is A, then pick that and move on. Okay. Just want to help you guys with these little strategies here. Elam, you put 7. Do you understand why it is 234? So we're going to be multiplying 39 times 6. So those two you guys both solved within 15 seconds. Okay. All right. Third one here. C. Now, you may not remember that from geometry. Okay. What does X look like? The angle. It's a vertical angle. Okay. But the degrees of X, does it look the same as 145? The same. Okay. They put on here these words, not figure, not drawn to scale, kind of to cover their tail. It's the same. Okay. 145. If it looks the same, based on my experience on the SAT, they're pretty much drawn to scale. Okay. I have not seen, and especially since they've redone the whole SAT as of a year and a half ago, I have not seen one that was outlandish, that showed like an acute angle when it was really obtuse or whatever. Okay, so let's do it again. Number 4. Oh, wait, well, hold on, let me think about that. This one's short answer. See if you can solve it within the 15 seconds, okay? It is 11, okay? Now, if you didn't get that, it's fine, okay? That's okay. That is okay. Most of my students wouldn't. Okay, I would say flag it and move on. That would be my strategy for that. You can. Now, I know you don't have Desmos right in front of you. I would recommend using Desmos if you don't know how to do it off the top of your head. Okay, so the total cost is always going to be what it's equal to. This would be 58 equals 14 minus 4x. And then you can see right here, it's 11. Okay. Oh, I put minus, it should be plus. There you go. Should be 11. Okay, try this one. That one was close, but it is C. Now, I'm going to help you guys with this. On the left side here, what can I factor out? And what am I left with when I factor out 4? So if I factor out a 4, so think about what you just said. You said it properly. If I factor out -4 from the whole thing, you have 4 times x minus 7 equals -6. And your answer is -6. You actually get the answer when you do that, when you factor out a 4. I'll explain what I mean by that in a second. Okay, it's just an alternative way of thinking about it that can help you get to the answer a little faster. And it's asking for the value of x minus 7. So if I notice, oh, well, I already have a 4 in all of these. That's your answer. Okay. Yeah, anyway, math. Okay, that one was good. Okay, right at 15 seconds. Now, don't feel like, I do want you to feel pressure in this instance where you're like trying to get yourself on the clock of 15 seconds. On the test itself, 15, just keep a mental note of I need to make these faster, okay, than whatever your normal time is. By doing that, you're going to be banking up all this time per question so that you can allocate that for all these short answer ones that we're not answering yet. Okay, it's very important. All right, let's do this again. Next one. We'll skip this one. We'll go to, okay, this one here. This one mirrors one that we've already done. So you got to think about this. Oh, Jesus. That scared me, clearly. Okay, it's fine. It's B. Okay, this one models the other one that we did, okay, with the identical data sets, and then we're adding a number that's bigger. Gonna make them go up. Okay, now this is a totally different test. Those two questions were almost identical in form. You notice that there's some patterns here. Okay, now that one was just slightly over the 15-second mark after my soul came back into my body from being scared. So just keep in mind, keep it very close to that 15 seconds.
I'm sorry.
Mm-hmm.
I meant to say A. Would that be A? Plus the other numbers?
Oh, thank you. Yes, it is A. The mean of the original will be greater than the mean. Yeah. Sorry, that's my fault. Yeah, good catch. Because it is less than. Now, the form of it is the same. Okay, so we have two identical data sets, and we're adding a number to it. We just have to figure out how that's going to fluctuate the mean. Good. That's a good catch. Okay, let's do this one here. Now I will help you if you can't solve this within the 15 seconds. Correct? It is not A or B. Think about your slope. It's going to be D here. Okay. Now, our slope is negative. So that 3 has to be negative there. Okay. Now, it's not A or B because that is a less than symbol, and our graph would be shaded below. Okay. Now, again, you guys don't have Desmos in front of you. I would recommend just using Desmos. Okay. It will show you when you type this into the calculator, you can literally type in your answer. Y is greater than -1 minus 3x. There it is. Okay. At least verify that. Okay. Which expression is equivalent to this one? Okay. So, oh, let's do this one again. All right. Here we go. See if you can get this one. You said D? B. It is B. Okay. You have 8x cubes and you're taking away 1x cubed. So you have 7x cubes left. You have 8. And then when you distribute that negative, it's 8 plus 2, which is 10. Okay, let's say you didn't get that. Let me show you how. You go over to Desmos, you type in 8x cubed plus 8 minus okay, there's my original. Then you type in, remember, we're looking for an identical graph on top of it. We want it to be equivalent. 7x cubed plus 10. Okay, and it overlaps. It's indistinguishable. That means that it's equivalent. So if you're not getting it, okay, just by logically looking at it, please use Desmos. Okay, it's going to really help you. Okay. So let's do this here. Okay, I want to give you guys an opportunity to answer some of these independently. I'm going to give you guys, so let's do this. For the remainder of the time, I'm going to pull up some questions on here. Let's see here. And I want to give you guys an opportunity to answer them. Or do you guys, wait a minute, you guys have your packets, right? Okay, go ahead and go to module 2 for math and try to answer the first, say, yeah, try to do the first 15, okay? Now I'm gonna set the timer for that. Let's see, 15 seconds. Okay, that would only be about 4 minutes. See if you can answer at least the first 10, I would say, okay? In module 2 for math, okay? So ELAM online, if you want to open up another practice test, or you can keep working on this, what I'm going to do for the remainder of the time is allow you to focus on trying out some of these questions, okay? For in-person here, I'm going to set a timer for 4 minutes, okay? And then we will discuss what that's going to look like right after. About halfway there. Okay, 1 minute left. Okay, 10 seconds. Okay, that's time. So let's go over the answers, okay? If that felt very strange to you, do some practice. Okay? Over the next couple days, make sure that you can gauge and work yourself out and get used to being under that time crunch, because you have to allocate time for the future ones, okay, for the later ones. All right, so number 1 is B, as in boy. Number 2 is A. Number 3 is B. Number 4 is A. Number 5 is B. 6 is 6. 7 is 10. 8 is B, as in boy. 9 is A. 10 is A. Okay. Did you get any wrong?
I got
10? Okay. So 9 and 10 we need to go over. Did either of you get past that?
I got 13.
Okay. So 11 is D. 13, or excuse me, 12 is C. 13 is 774. And then 14 is 5. 15 is B.
So you're supposed to keep
No. I just was wondering if you guys had gotten anything past that, if you just chose to or not. You just went to 10?
Yeah.
Okay, perfect. So 9, what'd you say?
No.
Okay. So 9 and 10 we need to go over on here. Alrighty. Let me get out of this guy. Now it might be something silly that you missed.
Oh, it totally is.
Yeah,
I got the
that's.
ratio for it.
Oh yeah, so that'll do it.
I did this 1 to 6.
Oh yeah, well, that's.
So then we 2 plus.
No, it's okay. All right, let's see here. This is. Oh wait. There we go. Okay, so we've got. This is not the right one. 6. Here we go. I went back too far. This is the one here. Okay, 9. Yeah. So we've got like this. Okay, so yeah, 102 divided by 6. That's okay. That is okay. So what did you get for 9? You got D?
Yeah.
Okay. Now think about it again. So think about that logically. This value down here is less than this value. So D is not a logical answer. Neither is C. Okay. Just as you're going through it, make sure that you're double checking, saying, does it make sense? Okay, before you select it. And number 10. Oh, so this one, we would just divide both sides by 7. So it's going to be option A here. Okay. Now these, I hate these types of questions because it doesn't actually ask you to solve for X. It just asks you to take one step. It's like, do the first thing and tell me if any of these are equivalent. Now, this would be a great thing to do on Desmos as well. You type in your answer choice, type in your original equation, and see which ones overlap. Okay, super, super simple there. So for homework tonight, I do want you guys to give this method a shot. Okay, the goal though would be to get 100% within that time frame. Okay, to get all of the beginning ones correct, I would say if you can get up to question 12, that's halfway through. I said question 10 because that's really the end of the easy part. And then from like 10 to 17-ish, that's the middle part. And then everything after 17 is going to be pretty tough. If you can ace that first 10 in the 4 minutes, okay, it's really 3 minutes and 45 seconds, but 4 minutes, if you can get it in 4 minutes or less and 100% accuracy, you're setting yourself up way for success to have some time to think through the other ones. Okay, so for homework tonight, I definitely want you guys to try that on 2 different modules. Okay, I'm going to write it down on here in our notes. Same type of thing. I want you to do it on digitally so that you have access to it. I will write it down in here for our notes. So let's do practice test number 7. Module 2 on math. And I'm writing this down so you guys will get this in an email as well. Answer questions 1 through 10, and aim for 3 minutes, 45 seconds. Okay, and 100% accuracy. Okay, same thing on practice test number 8. So you're talking about less than 10 minutes of homework I'm giving you, if you can do it. Okay, now aim for 100% accuracy. So I want you to time yourself. I want you to see how you can do on it. But same thing, module 2 on math, answer questions 1 through 10, aim for 3 minutes, 45 seconds, and 100% accuracy. Tomorrow, we're going to be working on the latter half of the test. So we're going to be starting with like question 12-ish, 13-ish. And you guys are going to see approximately how long it takes us to answer those. A lot of them are going to be over a minute. Okay, so it's very pivotal that we save up all this time in the beginning part, the easy part, so that we can allocate enough time. And we'll probably work out of, we've already done, you guys did 4 already, 5 today, 6. So we'll probably do maybe 7. We'll probably, work on number 7 because you guys will have already done the first part. So we'll probably work out our practice test number 7 tomorrow, working on the latter half. Okay. All right. Well, good job today, guys. Enjoy your leg day.